Welcome back. So the next big question is why object-oriented programming? And along with that in this video, I'm going to show some of the first code that has to do with OOP and also introduce two topics, or two big ideas, encapsulation and abstraction. But let's start by talking about why object-oriented programming. It's important to mention that OOP doesn't allow us to do anything we couldn't do without OOP. It doesn't unlock any doors or functionality that we didn't have before. Remember, plenty of programming languages out there don't even support OOP, period. So they're capable of doing the same thing at the end of the day. We could make a poker game in each language or each type. But OOP is just about how we structure things and organize things. And it's really a human way of thinking, of creating these specifications and classifying things. For example, we have animals in this world, right? However many, hundreds of thousands, millions, probably millions of species, but I don't actually know. We have all these species, and they're all animals, but we classify them into smaller groups. We organize them. That's a very human thing to do. Well, with OOP, we can do the exact same thing. And this analogy isn't just limited to the idea of classifying things. Actually, if we take an example like this red fox, species is Vulpes vulpes. Well, not only does it belong to species, but it also at the same time is part of the Vulpes genus and the Mammalia class, which in itself, it's called a class. It's the same idea, classifying things, and it's in the domain Eukarya. So what this shows us is a topic we'll learn later on called inheritance, where we can actually have classes that are related to other classes. So this one fox at the same time is a species. It's also a mammal and a eukaryote. And anyways, I'll leave it off at there, but I just wanted to show this analogy doesn't just end at the idea of organizing things. When we talk about inheritance, this will actually show up again. So OOP is really just a nice thing we can do in our code. That's what it comes down to. So the why is that it's easier for humans. It's how we think. It's easy to organize things. It's nice and pretty, and we put bows on things, but it is not a fundamental thing you have to do to make things work. It's just to prevent yourself from going crazy and getting headaches and creating really long files. It's just a way of breaking things up or breaking them down and classifying them. Earlier, I mentioned the term encapsulation. Here's the first time it's going to show up. The goal with OOP is to encapsulate our code into logical, hierarchical groupings using classes. So once we learn to define our own classes, we'll be able to take a giant application, a program, whatever it is, and break it down and encapsulate it into these individual classes. Suppose we're making a poker game. So we want to model poker using Python. We don't have to make any classes. We don't have to do anything. We don't even have to make functions if we wanted to. You could do everything one line after another. It would be very repetitious. A lot of people would call it spaghetti code because the logic for poker is actually quite long to do some of the comparisons to figure out what hand beats what. But let's just not even get into that detail for now. Let's just say we are going the object-oriented route and we want to organize things into classes. Here are some of the distinct entities we might come up with. Oh, that's a picture. So we could have a game class. So every time a new game is started, all the functionality and data associated with a game is in a game class. Then a game could have multiple players. So each player has information like, their name and their bank balance or their chips balance. And then we have things like a deck. And a deck would have, information about the cards. So there would be a class for each card potentially. A card would have a class, a suit, a color, red, or maybe just suit, and then a value. Is it a king or a 7 or an ace? And then a deck would consist of, or at one point would have 52 cards in it or more, depending on how many decks we're playing with. And then, a poker hand would consist of multiple cards and chips, potentially, bets. There's so many things we could do. Maybe we're playing on teams, so we could create a team class. It's really totally up to us. And that's where the bulk of the challenge with OOP comes in, is that it's about figuring out what needs to be its own class. So it's not always about making every single possible thing a class, because if there's going to be just one property in there, one attribute, and no functions, then maybe it doesn't need to be a class. So that's kind of the skeleton, and we'll talk a lot more about that. But I don't want to just show you a slide here. I want to actually show you a quick example. So here in this file I called poker.py, I have a half-baked representation, not using OOP, just using functions, and that's it, to model decks of cards. So we have cards and a deck of cards. So the first thing I'll show you, there's a function called resetDeck, and all it does is it returns a big list of cards. And I didn't even go with 52, I just did 24 cards. So you can see each card has a value, like ace and a suit, hearts, and then the ace of diamonds, the 3 of hearts, and so on. And then we're just putting them all together into a giant list and returning that at the end. So then to start a new game or to make a deck, I would call poker deck equals reset deck, and that gives me this right here. Okay, then let's say I want to shuffle the deck. Well, we have a shuffle method from random, so then I can just call random.shuffle and I pass in the deck. So we're passing deck in. And poker deck itself is simply a list. Its class is a list, so no OOP yet. Then I have a function called deal hand, and it's up here. And what it does is it takes in a list of cards and then a number of cards to deal. And so it will take, let's say I pass in my poker deck and then I tell it to deal 5 cards. We're playing, 5-card draw. Is that what it's called? I actually don't play that much poker anymore. So we want to deal 5 cards off the deck, and it returns 2 things. The deck, which has been altered, it has 5 fewer cards, and then the hand, the 5 cards that came off. And we could return those as a tuple. And then down here, when I call deal hand, I can assign poker deck to be the actual deck that comes back, and then hand 1 to be the hand that we get back. So this is kind of a lot of work. If we look at what's happening here, we're basically passing poker deck into everything. Anytime we want to use the deck, the associated functionality with the deck, shuffling a deck, creating a new deck, dealing hands from a deck, we pass a list all over the place. And contrast that with the OOP approach. Okay, so here's an example using OOP. Now this is not all the code. In this file, I've actually defined all of the classes. And this one does more than the previous example. But what I just want to show you is how our code is organized and what it looks like now. So I have a deck class. So to make a new deck, I just call deck. And we'll talk a lot more about how we create classes in the next video. But notice the functionality, deck.shuffle. So I don't pass in a list anywhere that represents the deck. All of the associated code is inside of this deck. It goes along with the deck. Same thing with dealing a hand. All I have to tell deal hand is how many cards to deal. And then, it automatically knows which deck we're talking about, what the information is. It's all encapsulated inside of this deck. So if I actually really quickly showed you here, here's a definition for the deck class. And you can see there's methods like count or deal, shuffle, deal a single card, deal an entire hand. All of this functionality is inside of deck. So the whole point of that was just to show 2 ways of accomplishing the same thing. One, the OOP version actually involves more code at the end of the day, but it also results in an easier to understand and to think about organization for our program. All right, next I want to talk about encapsulation. So when we talked about modeling a deck of cards, let's just focus on deck and leave all those other entities alone. What are the possible things a deck would need to have, pieces of information, and what are the things it should be able to do, the methods? Here are some examples or some ideas. We could have a deck class, and it would have a cards list. We'll talk about private and public in just a moment. A cards list that would store, the actual cards in that deck. Then we could have a max cards attribute potentially. So when you're playing with a single deck, or if you go to a casino in Las Vegas, a lot of times they play with 2 or 4. I don't know if that's actually right, but I know it's more than one deck a lot of the times in a shoe of cards. So we could store that information. There might be a shuffle method to mix the cards up. A deal card method that will just take 1 card off the top. And then a deal hand method that might call deal card, and deal hand will take 2 or 3 or 5 cards and return them. and then count how many cards are left in that deck. So this is just some examples of the functionality and the attributes for one deck. But now I want to talk about this idea of private and public, what these underscores mean. We'll talk a lot more about it as we progress. But the idea is that some things don't actually need to be exposed to the outside world or to the programming outside world, where it can just stay inside of an individual deck. For example, the list of cards. The list of cards is not something that we need access to directly. We can access them through deal card or deal hand. Same thing with max card. That can stay inside the deck versus something like shuffle or count, deal card, deal hand. Those need to be exposed. And before we go any further, I should just be clear, Python does not actually support true private or public variables or attributes or methods. There is no distinction. So the way that we make something private, and I'm doing air quotes right now even though you can't see me, is by putting an underscore in front of it. And that's just a way of giving it a name that makes it clear to other developers. This is only to be used inside of a given class, not outside. It's not supposed to be public. Even though there's nothing stopping from someone accessing it, it's just a convention. And that's all that Python supports. So there's no way of actually preventing a piece of data or a method from only being available inside a class like you could in something like Java. So the entire point of this slide is to show you can take an entity like a deck and break it down into the pieces of information, attributes it needs, and methods, and not all of them need to be available outside of that individual class. And this leads us to the term encapsulation. So encapsulation is really referring to the grouping of public and private attributes and methods into a class, making abstraction possible. Okay, so we haven't talked about abstraction yet. That's the next slide. It really comes down to kind of what we already talked about. When we make a class, we only want to expose the bare minimum, the things that we might need to use from another class or outside of the class. And everything else, we just keep it inside, encapsulated. I like to think of it as a little bubble. We want the fewest entries and exits in and out of that bubble. So for example, we decided that the cards list inside of a deck is private. We're never going to directly access .cards. Instead, we'll deal a hand or shuffle the deck, which will in turn, each of those methods internally will work with cards. But we might want something like the length of the cards, how many cards are left in the deck, to be accessible. But if we're going to make cards private, then instead we could make our own public method called count or remaining cards. And inside of remaining cards or count, it could run .length or len of cards and return that. So we'll spend a lot of time talking about how you decide what to expose to the outside world. And again, there is no real distinction in Python. Everything is public. But if we are a good developer, we follow conventions and we leave things alone that are designated private, even if they're not officially private. So this leads us to abstraction. Abstraction is just the idea of exposing only the relevant data or the bare minimum of things to create an interface to something more complex. So we hide the inner workings away. We abstract that away and we provide an interface into that. So with the deck example, we hide the cards, all of the cards, and we just create these little interfaces in to shuffle them or to deal a hand or deal a card. Think of a more real world example, like if you're driving a school bus or any car would work, we have a steering wheel. We don't have to know about all the inner workings of how the steering wheel works and power steering and everything that's happening behind the scenes. We just turn the wheel, that's our interface, and it does everything else behind the dashboard or behind the scenes and underneath the car. It's kind of a dumb analogy, but same idea here. We hide the inner workings and we just expose what's needed.